we have a function f of x, like we denote y is equal to f of x. What does that mean? When x is getting some values, then this y will become f of t. For example, we'll take y is equal to f of x, that is a function of x, that means y is dependent on x, it is x square. Okay, so when x is equals 5, then our y value will be what? It is f of 5. So we get 5 square, that is 25. Okay, so how to represent this in a graph? So 0, see here, whatever the things we have x, this is y is equal to f of x. When we substitute 5 over here, then we'll get 25 here. Is it? Alright. Now, what if a value before 5 is substituted, like nearly 5? Here x is directly equal to 5. What if it is not equal? So we say when x approaches 5, when x approaches 5 means what? It is going from 0 to 5. Okay, so like we'll say limit x approaches some number, this f of x is exist and finite, then the function is said to have a limit. So here the same scenario we can write limit x approaches 5, f of x is equal to 25, like we can write. That means when x is approaching towards 5, our f of x will be approaching towards this 25. Okay, what is there? Directly you can substitute 5, 25 will get. But it is not working like that in many cases. Okay, how it works means we'll have a neighborhood. Neighborhood of a point A means here one point A, what are all the points near to those is called neighborhood. Like a small distance a minus h, and this is a plus h will take. So your house is here, who are all you call a neighbor? Those people who are near to your house, like this circle. What about this big circle? They are also another neighbors. This another big circle also a neighbors. The thing is how far they are. In what distance we call them neighbor. That is important. Okay, so this is the point A. Okay, so this like will denote one neighborhood. So this interval can be considered like modulus of x minus a, and the length of the interval be delta, like we call it. Okay, so x minus delta should be less than, x minus a should be less than delta. Delta is what? A very small quantity. Okay, this neighborhood. So what will be the behavior of f of x here? So here f of x is there, right? That is y. So for a minus h we will be having f of a minus h. This will be f of a minus h, this point. For a we will be having f of a. Here one neighborhood will be created, right? See, this neighborhood will be created. That also will have a length, the distance. So that we will call it what? F of x, considering f of a, not f of e. This is the limit L, like we will call it. So this L as the center, that will be less than epsilon. Okay, the same definition in that manner. So if x approaches to a in the neighborhood of a, then for every delta greater than 0, here whatever the radius you take, whatever the length you take, there exists one epsilon greater than 0, because whatever delta we have, here some epsilon will come. That epsilon is a small radius or small distance, like we call it, such that this modulus of f of x minus L, which is less than epsilon. This happens for all x in the neighborhood of A. This might sound confusing. Okay, see, we'll take this example itself. Here x is approaching to 5, I said. This A minus h means here 5 minus h, like we call it. H is what means a very small distance, like 0.000000, some 1000 zeros 1. If you say that is near, it is more near than that. Like this, like approaching to 0, like that, we should take that distance from the pointer. Okay, then if 5 minus h means what is 4.9? I'm just taking this example. That will be coming near to this 25, right? Like that. Here 5 plus h will get. That is 5.1 square. That is also coming near to 25. See, for this, this is very long distance. I'm talking about very near distance. Okay, so that much close it will get. That is what the purpose of the limit. You might get one question: why we have to study this? Why this has to approach like that and all? Because, shall I erase this? Am I audible? Okay. There may be some situations we have to estimate the value of a function. Okay, let us take this example. F of x is equal to 1 by x, like we take. Okay, suppose if x is equal to 0, then we say this is 1 by 0 and it is not defined. Is it? Is it or not? Is it or not? Okay, but instead of it is getting directly 0, what if it approaches to 0? Okay, like from right side, because this value is not defined, right? We might not get the exact value, but we may get where it approaches, where it is towards, like that. So from the right side of the 0, here, like this is 0 plus h means one small quantity I told you to take, right? For this function, x value and the f of x value will take. So x value is 0.1 I am taking. Then f of x is what? F of 0.1, that is 1 by 0.1. What is that? 10. Okay. And then x is 0.001. See, it is going towards 0. Is it? So then what will be our value? 1000. 0.000001. Then like that 1, 2, 3, 4, 5, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Like that the value will increase from this side. What happens when you approach from this side? Like minus 0.1 I am putting. Note is not same. Minus 10. And this is minus 100 when you put 0.01. So it gets approaches to minus infinity. So when you approach from this side, it will be plus infinity. When you approach from right side, it is plus infinity. When you approach from the right side, the left side, it is minus infinity. So it is not getting any feasible values. This like the graph will be. Okay. It never reaches the value 0. So you can estimate where it goes like that. Yes. Yes. That should be a finite place. What I said. Limit exists when we say. That is exists and finite. Okay. That is a finite number. It should reach to a finite number. Then only you can say it is the limit is exists. Limit does not exist. Yes. Okay. Now, still we have to continue something. One-sided limits. One-sided limit means any points. That's all. You get the idea of limits, right? Next, deleted neighborhood. See, deleted neighborhood means yes. Yes. See, I'll give you some more examples. The deleted neighborhood of A. As we have seen, when you approach from this side, it is not approaching, right? So, you get f of x, that is x plus 1 if x is greater than 0, x minus 1 when x is less than 0. As you can see, this function is defined on where? The real number minus, difference 0. Except 0, the function is defined for everything. So this kind of things we call it as deleted neighborhood of a point. This, as we are going to discuss, the value of the function near 0 only. But 0 is not there in the case. It's not there in the whole picture. So we call it as deleted neighborhood. Now here what happens? That is what? That is where this one-sided limit comes. So it is right hand limit. Right hand limit means from the right side we are approaching. So limit x tends to a plus f of x like will denote. Then this is limit x tends to a f of a plus h. And or we can say limit h tends to 0 limit h tends to 0 f of x plus h. Okay. Alright. And left hand limit. Left hand limit means from the left side we are approaching. From the left, that is 0 minus h. So it is denoted by limit x tends to a minus f of x. That is limit x tends to a f of a minus h. Or in h notation, limit h tends to 0 f of x minus h. Okay. So in this example, like here I wrote one function, right? So the left hand limit, right hand limit. Say we have the value 0, like the right hand limit will calculate, that is simply RHM. Limit x tends to 0 plus f of x is equal to limit h tends to 0 f of 0 plus h, like we'll write. So f of 0 plus h means we are substituting a value which is more than 0. Is it? Substituting value more than 0. So when you substitute more than 0, this output will come or this output will come? Oh, sorry, this is f of a plus h, and here also f of a minus h. Limit h tends to 0. Okay, then this first result will come. Then we'll get limit h tends to 0, 1. If there is any h, we can make it as 0. We make it approach 0. So we'll get plus 1 as the value. And left hand limit, that is limit x tends to 0 minus f of h. That is left hand, that is 0 minus 0 is a point that is x is approaching. So limit h tends to 0 f of 0 minus h. So wherever x is there, we should substitute 0 minus h. Oh, sorry, my bad. 0 plus h in place of x you should substitute. So 0 plus h plus 1. Okay. Then h becomes 0, we get plus 1. Like that, f of 0 minus h means wherever x is there, we should put 0 minus h. Whether this output will come or this output will come, we should check. So it is 0 minus h. It is above h, sorry, above 0 or below 0. Below. So this output will come. So we'll put limit h tends to 0, 0 minus h minus 1. We can make h as 0, then we'll get minus 1 as the answer. So limit is what? A destination. So when we approach towards a particular point, the destination should be finite and it should be unique. So here 0 I talked about, I spoke about 0. So when we come from the left side, the left hand limit, it approaches to minus 1 when we come from this side. Simply I am putting, this is minus 1. Okay. When we come from the right side, it goes to plus 1. Alright. Whether they are going to a particular destination or it is scattered around. Particular destination, okay, but they are not meeting. It should be the same point. Okay. So the left hand limit and the right hand limit should be same, should be equal. Okay. So we say the limit is does not exist. Alright. And one more example. No, it is not h also. H tends to 0 in all the cases. As I told you, h is a very small difference. Is it? That always approaches 0. It is not just because of 0. Okay, this is the case for 0. Let us take for the same function, the value 2 we will take. We will approach from left side, we will approach from right side. What we will get? When x approaches to 2 plus f of 2 plus h. So wherever x is there, we will put 2 plus h. Then we will get 3. Then when x approaches from the left side, from this side it approaches means here, this is also 2, this is 2 minus h, then what it is 2 minus 1, 1. Wait, that should not be 2 plus h, 2 minus h. Yes, sir. See, we know about the destination. When we directly substitute one value comes. Whether there is any break in between or not, we should check. Then only the path will be smooth. Okay. Like when you when you substitute directly, you may get the answer, but that may not be the answer from the left side, from the right side as well. Let me give you one more example. The modulus function will take. No, not the modulus function. F of x will be some x plus 2. Wait. Sorry, my bad. What about the previous example? X plus 1 when x is greater than 0. X minus 1 when x is less than 0, right? We spoke about the point 2. So limit x tends to 2 minus. 2 minus means what? That limit h tends to 0, f of 2 minus h. Alright. 2 minus h means whether the value is more than 0, less than 0, we should check. Okay. You might think, what if it can be 2 minus 5? No, it is not. Because that h is what? Very small quantity. It will be very near. So, we will be getting 1.999999 like 1000 nines. Like that, very small quantity. Whether it is greater than 0, less than 0, we should check. That I didn't check in the last scenario. So, limit h tends to 0. 2 minus h means this output or this output. Whether it is more than 0 or less than 0. It's more than 0, right? More than 0 means then here 2 minus h plus 1. So, we will get, when h approaches 0, we can substitute h as 0. Then we will get 3 as the answer. The same way, the right hand limit, x approaches 2 plus f of x is equal to limit h tends to 0, f of 2 plus h. So, whether it is more than 0, less than 0, we should check. That output is last time we applied this. More than 0 means this first one. So, limit h tends to 0. This is 2 plus h plus 1 again. So, we will get 3. So, here left hand limit, right hand limit both are equal. We say the function is having a limit at this point when it approaches to 2. Whereas, when it approaches to 0, yes. See, for that also we have methods. Okay. So, in the question itself, they may give x approaches this, x approaches that, and that point you should check. Just to explain you about this concept of limits, I am saying. Okay. It is not that only to this point this function will approach. It could be any point. But we will be focusing on some critical points where the limit will be difficult, whether it will be exist or not. Okay. Now look at this one. Limit x tends to 2, x square minus 4 by x minus 2. What happens? As you thought, as you think like previously, substitute the value directly. 2 square minus 4 by 2 minus 2. Then we will get 0 by 0. The value may not exist. This indeterminate form. Whereas, we will simplify this. X approaches 2. X square minus 4 can be written like x plus 2 into x minus 2 by x minus 2. This x minus 2, that x minus 2 gets cancelled. Then remaining limit x tends to 2, x plus 2 like we will get. Now, here also we can make sure left limit, right limit like that. Okay. So, here left limit when you put, what you will get? Four. So, A means that point 2. Like that, limit x tends to 2 plus, that is also 4. Okay. So, this function is having a limit when x approaches 2. When you say here, it may not exist, but when you simplify, this both left and right limit will exist. Okay. Yes. See, in some scenario, you might not needed to calculate this left limit, right limit null, because here we substituted, we get like 0 by 0, then we factorize, then we check. Okay, but in some cases, the answer may be direct. Okay, and then next. There are two more definitions are there. Like, I think you may get some idea about the limits, right? Okay. See, like a note or definition, whatever it is, we'll be saying this f of x is approaching, see, as limit x tends to a, f of x is equal to L only if the both left limit and the right limit they approaches L. Suppose they are not equal, like in the previous case, plus 1 minus 1 coming, we say it is does not have the limit does not exist. Okay, but whereas there will be a remark or few more definitions, we will call it. The function is defined not defined. The function is not defined, not defined on the interval a comma a plus h. A comma a plus h means this is the interval I am talking about. So I will be putting a minus h and a plus h, right? So in this interval it is not defined. It does not depend on the value on this interval. Only this. Then we don't need to care about this value. No, it is need not to be equal, the left limit, right limit. Then we say what? If the left limit alone exists, okay, that will be equal to the limit of the function. Okay, and suppose the function is not defined on this interval, like this a minus h comma a, then we don't need to care about this value, only right limit exists. That right limit will be the value of the limit of the function. Limit extends to a plus f of x will be limit extends to a f of x. I'll say once again, see, we say the function is having a limit only if both right limit and left limit exist, provided that it is defined on this particular neighborhood of a. Neighborhood of a means I talk about this one, a minus h comma a plus h, that nearby points. Okay, so suppose the function is not defined in one half of the neighborhood, this right half is not defined, then left limit alone is the limit of the function. Or else if left part is not defined, in the left part of the neighborhood the function is not defined. Not defined means we don't have any values, like I told, deleted neighborhood, limit extends to not limited, f of x is equal to like x plus 1 when x is greater than 0, just like you are saying. Then that means what? Only the right part of the limit exists, that is 0 comma 0 plus h exists. Okay, whereas the left part is not even defined, we have only for this. So in that such scenarios this will happen. Alright, do you have any doubts on this? Okay, now we are having some theorems on limits. The theorem 1. You heard about the constant function? Okay, then whatever the value it is, then limit x tends to a, that a could be any value. This function f of x will go to c only, then no other point. Why? Because for all the values it is going to c only. So whatever the point you take, then again that also will go to that particular point only. Okay. For any a belongs to R. Okay. And the next theorem, we have the function f of x is equal to x. That is the identity function. Input is equal to output. Then what we might have, limit x approaches a, f of x, that is also equal to a. Okay, for all the a belongs to R. Okay, and then one more theorem. So where is this? The theorem 3. If limit x tends to a, f of x exists, then limit x tends to a, not x tends to a, this f of x will be equal to limit x tends to 0, f of a minus h, and that will be equal to limit x tends to 0, f of a plus h, sorry, a plus x. Okay, that means that this is nothing but the other variant of the left limit and right limit. Okay, now when I say x is approaches to a, when I say x is approaches to a, then x minus a approaches where? X is going to approach a, x minus a approaches to 0. Okay, that is the thing happened here. Then here x approaches 0, this f approaches where? F of a. The same way x approaches 0, f approaches f of a. That's all. They are equal. That is it. Alright. And these formulas I already told you. See, like limit x tends to a minus f of x is equal to limit h tends to 0, f of a minus h. What is this left hand limit formula? Then right hand limit x tends to a plus f of x is equal to limit h tends to 0, f of a plus h. And two more results. Limit x tends to a minus f of x is equal to limit x tends to 0, f of a minus x. The same way, limit x tends to a plus f of x, that is equal to limit x tends to 0 f of a plus h. They are nothing but different definitions of left limit and right limit. Okay, and then we have some results. Like it's more of a concept based. Is it boring or is it confusing? Little bit. Exactly at where you are having the confusion means, like what is all this? What is a plus? What is a minus? Where they are going to apply all this? Then let me give you one example. Say limit x tends to 1, 2x plus 1 by 3x square minus 4x plus 5. So what will be the value of the function when x is approaching to 1? Now the first question, here left limit, right limit is required or not? No, it is not. Because this is a single valued function. Single valued function means for all the inputs, we have this expression only. Unlike for the previous one, when x is greater than 0, one separate output will come. When x is less than 0, another separate output will come. Again, null, it is not. So here left limit, right limit not needed. It is not a separate function. Then what is the value of this? You substitute 1, that's all. 2 into 1 plus 1, 3 into 1 square minus 4 into 1 plus 5. So which is 3 by 3 minus 4 plus 5. So which is 3 by 4. This is the value. Okay. Any doubts in this? Suppose what will happen means, here when we substitute directly, the limit might not exist directly. So in that such situations, we might have to do some steps, do some measurements to find the limit. Okay. Alright, that is what this whole thing is about. So there are more and more concepts are there. We'll see the algebra of limits and some standard limits we'll see. That is it. With that, we'll go to the exercise directly. This exercise 2.1 you take. Look at the first question. Yes. Then the exercise 2.1, question number 1. Limit x tends to 3, 1 by x plus 1. What it is? 1 by 3 plus 1, 1 by 4. That's all. And then the second one. Limit x tends to 0, 1 by x square minus 3x, x square minus 3x plus 2. So we'll substitute 0, we'll get 1 by 2. Okay. That is it. Now look into the next one. Like all direct substitutions, right? Yes. See. Fourth one is easy, fifth one is easy, sixth one is easy, seventh one. See the question number 7. Limit x tends to 2, 2x square minus 7x minus 4 divided by 2x minus 1 and root x minus 2. So we'll substitute 2 in the place of x. 2 into 2 square minus 7 into 2 minus 4 divided by 2 into 2 minus 1, and this is root 2 minus 2. That is it. This is 8 minus 18 by 4 minus 1, 3 into root 2 minus 2. Then what is it? No, minus 10. Minus 10 by 3 into, here we can take what root 2 as common. Then this is 1 minus root 2. Then we'll be getting minus 5 root 2 by 3 into 1 minus root. Like that we'll get the answer. That is it. If you want, we can rationalize the denominator. Okay. Okay, now look into the 8th one. Limit x tends to minus 4, x plus 4, yes. So we'll get numerator 0, denominator 16 plus 4 minus 20, 0 by 0. So we should be factorizing it. X tends to minus 4. See, for this only we have seen that kind of situations, that kind of definitions, explanations, all those things. So we should factorize it. Yes, we'll see one by one. After completing this exercise, we'll go back to that one and we'll find out. Now this is by multiplication minus 20, addition minus 1. Because 4 5s are, as addition gets negative, we'll get big number negative. Then it is x plus 4 into x minus 5, right? And x plus 4 cancel. Then limit x tends to minus 4, 1 by x minus 5, which is 1 by minus 9. So it was minus 1 minus. Okay. Third one, first question. What it is? Third one, first question. Where it is, man? Okay. See, for that we should see some definitions, man, some formulas. Then only we can able to find it. That we came across. I think we skipped those things. After seeing those things, we can able to find this. Okay. Now shall we see that algebra of limits? Okay, so far what you understood? When we substitute the limit, it should be, if it is not coming, we should be factorizing. Okay. Then, just to understand this, the theoretical way, it is not that simply substituting the value getting the answer. It's all about the approach. The value of x is approaching to that one. Okay, we'll see. Now the algebra of limits. See, remember matrix we have seen. Immediately we have seen what could be the sum of two matrices, difference of two matrices, multiplication of two matrices, like that and all, and the constant multiplication. Like that we have seen limits right now. Now what could be the sum of the functions? See, we call it as algebra of limits. So let limit x tends to a, that means x approaches a, this f of x approaches L, we say. and limit x approaches a, this f of x approaches m, not f of x, sorry, g of x approaches m. Then this limit approaches x approaches a, the function f of x plus g of x will approach where, you guess? This L plus m. Same happens with negatives also. Okay, and the second one, limit x approaches a, f of x into g of x will approach where? L into m. And the limit x approaches a, f of x over g of x approaches, provided that m should not be equal to 0. This approaches L by m, this m is not equal to 0. So simply when we add those two functions, the limit can be added, subtraction also, the limit can be subtracted. When we multiply, the limit can be multiplied, and when we divide, the limit can be divided. Okay. And about the constant multiplication, limit x tends to a, this c into f of x, the constant, that will be c into the limit. That is, sounds easy, right? Okay, also few more things are there. L plus m minus m, okay. Limit x approaches a, this f of x minus L will approach where? This will approach L. So L minus L, that is 0. And the same way, limit x approaches a, modulus of f of x will approach modulus of a. Okay. Okay. And then some theorems are there. If limit x approaches a, f of x is less than or equal to, no. If the function f of x is less than or equal to g of x, then their limit also, limit x approaches a, f of x will be less than or equal to limit x approaches a, g of x. That means L less than or equal to m, that L and m. Okay. And sandwich theorem. Sandwich theorem means sometimes we may not get the limit of a function. Sometimes we may not get the limit of the function. Okay. So here this both f of x and g of x approaches to L, we say. Okay. Then if we can able to find one h of x such that h of x is in between this f of x and g of x. Okay, simply this x is a function we need to find. It will be less than or equal to x minus 2, and this will be less than or equal to x plus 2, right? So where these two functions is approaching, there only this function also will be approaching. This exactly looks like a sandwich, like in between this function is there, right? So as this f of x and g of x approaches to L, then this h of x also will be approaching to L. Okay, that is it. And there are several definitions as well, like limits of some elementary real functions. Those things are nothing but easy, directly you can write. That is it. That is about this first exercise. We'll solve some more questions in the first exercise, and then we'll proceed towards the next one. Okay, as the first question is easy, second question is easy. Second question, when x approaches 0, it's 0 only. Can't do anything about it. Yes. Short answer, third one, second sum. Okay. Third sum. Okay. Find the left and the right hand limits of the function at the point A mentioned against them. Hence check whether the function have limits at those points or not. We should be finding left limit and right limit. As I told you, when the function is having two different outputs, we might have to check the left limit and right limit. If they are equal, we can say the function is having a limit. If they are not equal, the limit does not exist. Okay. So this one, this third one, not f of x is equal to this x by 2 if x is greater than 2, and it is x squared by 3 if x is less than 2. So they said a is equal to 2. That means you should be checking left limit and right limit. Okay. Simply apply the right hand limit definition. What is right hand limit definition? Limit x tends to 2 plus f of x is equal to limit h tends to 0 f of 2 plus h. Okay. So 2 plus h means it is more than 2 or less than 2. So this output will come 2 plus h by 2. No, it is 1. Okay, when x approaches 0, it is 1. And the right hand limit, not right hand limit, left hand limit. Left hand limit is limit x tends to 2 minus f of x, that is equal to limit x tends to, not x, h tends to 0 f of 2 minus h. 2 minus h means whether it will be more than 0 or less than 0. Sorry, more than 2 or less than 2. Less than 2. So it is limit h tends to 0. This is 2 minus h whole square by 3. We should expand this. When we expand, what we will get? Expanding, not expanding, also no problem. 4 minus 4h plus h square divided by 3. When h approaches 3, we will get 4 by 3. Left limit, so right hand limit is coming 1, left hand limit is coming 4 by 3. Are they equal? So therefore, the limit does not exist. No need, because the function, the definition itself not there, right? It's a deleted neighborhood. Okay. Do you have any doubts in the limits? Still it is confusing, is it? Look at the fourth subdivision. Questions are easy, but the definitions are difficult, right? It's alright, first time it will be like that only. As you go through all this, that could be easy. Okay. Then we'll solve some more questions of this, and then we'll finish with this exercise 2.1. Okay, that will continue tomorrow. Alright. Okay. Then that's enough for today. Just continue the matrices, finish it, and in the middle we may plan one doubt clarification for matrices. Okay. Okay. Take care. I'll see you tomorrow.